Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is advanced lighting systems. We're going to talk about all these new headlight systems that they're using on vehicles these days, and there's some crazy technology that's coming out that these manufacturers have been using for the last few years. So we're going to have to diagnose them because they're going to be coming into the bay. Now, some of these things, you're not necessarily going to be repairing them. Some of them, you can't even replace the bulbs anymore. But we're going to talk about it because I figure it's good to be aware of what's going on out there as we go. So first off, we have to talk about where we've been. So we're going to talk about the history of headlights. I know it seems kind of boring, but it'll go pretty quick there from about 1940 till today. We'll talk about projection headlights. So that was one of the first advancements from the sealed beam, is that they went to replaceable bulbs, then the projection, then HID bulbs. We'll talk a little bit about that. LEDs, which are going to be you're more modern in the last decade or so, and then intelligent lighting, talking about how it adapts with ADAS and adaptive lighting, and how we can automatically dim the high beams and all sorts of things like that. So let's start though with the history. And I'll stick to the US because it's a little easier for me to just keep the timeline. But in the US, two circular headlights was the standard pretty much beginning in 1940. So they were the sealed beam bulbs, just like this one right here. So it had a little tungsten filament in there. It was just a sealed piece of glass with some reflectors and different cuts in the glass to allow that beam to form. And it was two bulbs. That's all. That was it. You just had two bulbs, round bulbs in front of the car. That's all you get. In the late 50s, though, it was expanded to four lights, two for high, two for low beams. So that's when high beams first came onto the scene, so to say. And then finally in 1974, or actually in 1974, regulators began allowing rectangular sealed beam lamps. So I always remember back to like the Ford F-Series or the Econoline vans with the big rectangular lights in there. And then in 1983, they finally changed regulations would allow replaceable bulb aerodynamic headlights. So we didn't have to worry about the big old sealed beam glass things anymore. Now the manufacturers could make them out of plastic. They can make them more aerodynamic, curvy, nicer looking. And then we just replaced the bulb on the inside. So that was back in 1983. So almost 40 years ago is when they changed to that. And then the manufacturers kind of took that and ran with it. So they went through the 80s. Throughout the 80s, manufacturers started using more aerodynamic designs, and then projector lamps began in 1986 on the BMW 7 Series. So they started using those projector beam type headlamps, which give you a sharper cutoff and so on. That brings us to the 90s. So during the 90s, manufacturers developed HID lamps. So HID is high intensity discharge bulb, uses a high voltage, uses metallic salts in order to create an arc. And then that's what causes the light. So the first mass market HID lamps were in the 1992 BMW 7 Series. So there's that 7 Series again. Seems like that seems to be their experiment. Let's put in the new stuff into that model, right? And then the first 4-bulb HID system, so low beams and high beams, was in the 1999 Mercedes CL class. So that brings us right to the turn of the century into the 2000s. Now, starting in 2004, manufacturers started developing technology for LED headlamps. They didn't quite have it down until about 2006, 2 years later. First mass market LED lamps on a vehicle were in the Lexus LS600H. The first full LED system, where all the bulbs were LEDs, they didn't use any halogen, any HIDs. It's 2009 Cadillac Escalade, and those are their headlights right there. Fully LEDs, no other bulb types in there, and that was the first one in North America. Now let's talk about the projector lamp. So they can be used with both halogen or HID lamps. And what it does is we have our elliptical reflector back here where the bulb is in the back, and it'll bounce the light all over the reflector. Then it comes down into the chamber, and we have a lens right here. Now, depending on where the shield is, it can give us both high beams and low beams. Now, not all vehicles or not all projector beams have this shield. It's only if I have the two-way where I have a low beam and a high beam at the same time, and the solenoid will move it up and down and out of the way, so it can block off some of that light so it doesn't go through the lens, and that's where you get that sharp cutoff thing. So as I said, projector lamps can be used with halogen or HID bulbs either way. They use that reflector in the lens that gives the beam that sharp cutoff. Combo low and high beams use that shield to change the light pattern. So this shield right here is a little bit better view of it. So we have a solenoid, moves back and forth, in and out. And it's got this little cam here that moves the shield either up or down. So if it's down and out of the way, that's my high beams. It gives me my full output of the light. Or when it comes up, it gives me my low beam, and it gives me that cutoff at the top. So it gives me that sharp cutoff. So here's just an example of what that looks like. So we have the with the shield stop up, it's going to stop some of that light from getting through. And then with the shield rotated down, it lets all the light come through and allows it to go through the lens there. So, we can see how the light kind of bounces a little more uniformly with the high beam, makes it much brighter. But it allows us to do high beam and low beam both at the same. Next up is going to be the HID lamps. So that was in the order, and we can see there's the little tungsten filaments there, and then we have our salts in the middle, and they require a high voltage ballast in order to get them to start. So this says, looks like somewhere over 300 volts right there. Do not open, will shock, burn, or cause death. So we don't want to open that up. When we're testing these, we want to test on the input side, the low voltage 12 volt side. Otherwise, the high output side can hurt. So what they do is they use a high voltage arc to ignite between those two tungsten filaments. You do need an AC ballast. It doesn't work on DC, it works on AC, and an igniter to supply the proper voltage. You also may hear these called xenon lamps. Xenon gas is what they use inside that sealed bulb to get that arc started. Now the bulb has 3 different phases. We have the ignition phase, the initial phase, and then the continuous phase. So during the ignition phase, a high voltage pulse ionizes that xenon gas. So it's that it could be 10, 20,000 volts. Works very similar in principle to a spark plug. We have to get the spark to jump. It's going to require more voltage to jump the gap than it is to keep it going. So once it ionizes the gas, it lowers the resistance, and current is then able to start flowing. During the initial phase, it drives that bulb at a high power, high voltage, which causes the temps to rise rapidly in there. As it rises, the metallic salts that are in there also vaporize, which stabilizes the arc. Then during the continuous phase, once it is stable, the ballast is going to supply a constant voltage, stable power to keep it from flickering. They have different bulb designations. So D1 and D2 bulbs, you're going to see 85 volts AC. And on D3 and D4 bulbs, it's 42 volts AC there. So about half between the two. So it works on that principle of ionizing the gas and allowing it to flow. It forms a plasma, and the plasma is what glows and causes that very bright white light. Next one's LED lighting. So LEDs, as we saw there, stands for light emitting diode. Many benefits to these LEDs too. Longer lasting, so just lasts longer than a burning filament. Less power draw. Brightness is now better than HID. So in the beginning, they weren't as bright, but now manufacturers have gone through changes and developments, and now the brightness is brighter than HID bulbs. And HID bulbs taking all that power to start them up, a lot more benefit with the LEDs. That's why you'll see any hybrid cars, electric cars, almost exclusively LED bulbs. This also allows manufacturers flexibility in designs. I remember when they first came out with this Hyundai Tucson with the fancy LED lights there. There was like everybody's like, oh wow, you're blowing my mind here with these lights. They're not even the headlights, they're the daytime running lights. The headlights are down here. But they were just talking all about how it's so different. And it is. Yeah, it looks pretty cool. And it's a 5-piece design. So we have the housing on the rear. We have the reflector and LED assembly. That's what does all the work. You can see the individual bulbs in there and how they would kind of reflect. An outer lens to protect it, lens bracket to hold it all together, and then a garnish on the outside to blend it in with the grill. But the LED lights, there's some cool things they can do with LED lights. We'll talk about in a little bit, like dimming just part of it in order to dim the high beams and so on. So now let's get to intelligent lighting. So intelligent lighting is we're going to be dealing also with ADAS when it comes to this point, multiple sensors and servos, things of that nature. It allows us to move the bulbs side to side if we need to. Going around corners allows us to level them out if the load in the car shifts and changes. So many modern vehicles use computers to control the vehicle lighting. Of course, we have sensors and switches. Some examples include automatic headlights. I leave it on auto mode. When it's dark out, they turn on. When it's light out, they turn off. Automatic beam switching, so it can go turn on the high beams automatically for me, and then when a car approaches, it'll turn off the high beams or dim it, as we'll see in a little bit. Headlamp leveling, as I said, different load values in the vehicle. It can be a little heavier on one side or the other. It could be heavier front to back, so it's going to level them automatically as well. And then we talk about directional headlamps. So turning right, my headlights go right. Turn left, my headlights go left. Now they've had those for a long time back in the day with the Tucker. I know was one of the more famous ones that had that center bulb that did it. But now they, instead of doing it with a linkage, they do it with motors and sensors. Advanced front lighting, which would be being able to kind of form the beam, and then adaptive high beams again, able to adapt to their surroundings. So different manufacturers use different ways of going about this. There's a variety of sensors to do this. So a lot of them use a front view camera. Hey, I see a car with headlights coming the other way. Let's dim our lights. Sun load sensor. If I have no sun load, then the sun's not out, and that means I need to turn on my lights. Rain and light sensor, same thing. If it rains out, wipers on, headlights on. Or light sensor, they could use it with that as well. So if they don't see sunlight, then they'll turn the lights on. Actuator motors to move the lights back and forth, up and down, however they need to be moved. And then, of course, the computer needs feedback for that, so there's position sensors involved with that as well, and resets and relearns and things that need to be done. Here's an example on a 2019 Cadillac ATS. Now you'll see there's not a lot going into these lights. That's the left headlight, that's the right headlight. And we got power, we got ground, and we got network. There's 3 wires going in, power, ground, and network. So to test these, we need to test power, we need to test ground, power supplies. But we also need to make sure that it's getting the network connection as well. So it needs to be, it's getting data off the bus from a multitude of sensors. Could be a ride height sensor, could be steering angle sensors, and so on. Gets all that information and tells it what to do. So we have a horizontal motor, which does side to side. And then we have a leveling actuator, which goes up and down. And that's all kind of part and parcel of that headlamp. So it's a different way of thinking about diagnosing things when it comes to this one's even more fancy. So this is a 2019 Mercedes E-Class, and it's LED headlights. And what it does is it uses a matrix of those LED bulbs to auto dim the high beams. Now it can kind of turn them on and off and move them around. Adaptive high beams, they call it. And they have, you can see where all the LED connectors are. And this is the front LED matrix lamp kind of goes around like that. So we can see we have these elements in here, these adaptive high beam elements, and then the low beams in there as well. And then we can see all the other little LED matrices in there. Signal lights, fan motors, because the LEDs do generate a decent amount of heat, so they have fan motors in there. And then down here we have our inner left position light, running lights, outer left position lights, cornering illumination, and a couple more motors there. Also, to feed into the system, front level sensors and rear level sensors, so it knows, where's the vehicle in space, where is it moving. So some interesting tech there. This one's really interesting, I think. Laser lights. So they got cars with laser beams. Uses a blue laser light to generate a beam. As you're found on BMWs, there's a couple other manufacturers that I think have been experimenting with them. BMW has quite a few vehicles with it. Uses laser light to generate a beam that bounces off the mirrors onto a yellow phosphorus lens. So it's a lens coated with yellow phosphorus. That yellow phosphorus, when it gets hit by this blue laser beam, it's going to excite and it's going to generate a brilliant white light. Using this technology also makes beam forming highly adaptable. So let's watch a little video here. Car's going down the road, oncoming car. It's able to shape that beam and move things around and adapt it to that other car. And then it just brings it back the way it is. That's pretty cool. Let's play that one more time. So car comes in, it adapts the beam around it. When it finally comes close enough, it just sucks it in, and then it stretches it back out. So I really don't have to do anything. I don't take my eyes off the road. I don't have to touch any buttons to do this. Another benefit of this, I was reading in an article today too, that they could use this as like a heads up display. So actually could project things on the road in front of the driver in their field of vision, like speed limits, things of that nature. Actually project that onto the road. And I think that's kind of cool. It's almost like that augmented reality, the AR stuff that's out there. It's kind of neat. Makes it a little safer. Also, the beams can go about half a mile down the road, which is way further than we can get with other existing technologies. So maybe eventually the price will come down, because I'm sure they're actually, we'll see how pricey they are here in a little bit. But interesting technology, and it's coming to a shop near you. All right, let's switch over to my Zeus Plus. Yep. All right, so before we even go in and ID a vehicle on this, let's talk about, maybe I want to learn a little bit more about this stuff that I'm talking about. So if you have a snap-on tool with guided component testing, that'd be anything with a scope, so Zeus Plus, Zeus, Varus, Verdict, Vantage, Triton, Modus, any of those tools with a scope are going to have guided component tests. And in the guided component test, before we ID a car, you'll see there are classes in classes. And if we go into how to, there's a couple classes right off the top here. So we got HID lighting class. High intensity discharge HID lights are now being used by vehicle manufacturers as an optional extra on many models. May also be a standard fitment on top of the range model. This system replaces the standard filament bulb used for dip beam operation with specially designed bulb. The bulb contains two electrodes approximately 4 millimeters apart and a quartz bulb containing mercury, metal salts, and xenon under pressure. The advantage of this type of system are as follows. So due to the absence of a conventional filament, the lifetime of the bulb is greatly increased. I don't have to worry about that filament heating up, cooling off, heating up, cooling off. It can be as much as 4 times greater than a standard bulb. The driver will have a wider field of vision and greater illumination during hours of darkness, and it allows 2.5 times the light flux at approximately half the temperature. Light flux is the flow of energy from the bulb in the form of light. All right, so we also have a couple different ways that they can dim the bulbs. The system must be in place to automatically adjust the headlight level under transient conditions such as cornering or when the vehicle has a load. The lateral acceleration sensor can tell the vehicle dynamic characteristics using cornering to the electronic stability program. Signals then put in a CAN bus network where the HID control module can access the information and decide what to do. Or front and rear height sensors on the suspension so it knows what angle the headlights. Okay, and then there's a headlamp washer system will often be fitted as well. So it'll have the little washer nozzles to spray and clean off the lamp as well. So that's HIDs, and then we have priority lighting, which we didn't talk about here, but it's where we use multiple bulbs. Exterior lighting module can monitor the current flow through each bulb, and if a fault is detected, another bulb in the cluster can be used. Using the rear light set as an example, a manufacturer can fit bulbs of the same wattage for the lamp cluster. As opposed to using additional bulbs of a lower output, like 5 watts, this makes it possible to use another bulb in the event of a bulb failure. A warning light on the instrument panel will alert the driver to the malfunction, and then, of course, you would need to change the bulb. It uses a duty cycle, dim the output as well. So that's priority light. So there's all sorts of things in here, but those are the two that really pertain to this class. I know relays and things in there too, I guess. But there's a lot of stuff in here, so definitely worth your time to check it out. It's included with the tool. It's free. All right, let's look at some cars. Not that way. Activate. So this is a 2019 Genesis. Let's take a look at some repair information. Oh, geez, I'm signing in too much. Sign myself out. All right, so look up headlight. Okay, so we got some stuff here. So we got a component operation. It's going to tell us how it works. So we got a little bit of things about the HID bulbs, bifunction bulbs, which would be the it's got the projector beam in there as well. So it's got high and low beams, and that's where I got the pictures of the little flapper there. We got the solenoid. You can test the solenoid. You can make sure that works. You can test the connections there, make sure that works. And the LED panel is going to be more like a light panel. It's going to be LED module, cooling fan, and LED driver. And let's see. After repair, it's going to talk all about headlamp aiming. And yes, we are still using screwdrivers on some of these to get the actual lamps aimed. It's going to give you all of the measurements and things that you need to do in order to aim them, just like any other head. There may be a reset or a relearn that needs to be done on some of these. And then let's take a look. How long does it take? It takes about 2 hours to do both sides. You got to remove and install the bumper cover. It looks like that's the bulk of the time because it's only 2/10 difference between the two sides. And $1,700 for the headlamp assembly. That's one of the cheaper ones we're going to see. Just so you know. Let's see, was there guided component tests on this? I think there are, yes. So in the guided component test, there's also things for the lighting system. So if we go into body electrical and exterior lighting right here, we can see HID headlamps. If we go into information, it's going to tell us how they work now, where we already read through the operation there, but it can be up to 20,000 volts to start that arc. So just be aware, stay away from the business end of that. You want to check it on the input side. Vehicle is equipped with a set of high-intensity discharge headlamps. These headlights implement a ballast igniter, which increases the vehicle's battery voltage to a high voltage in the region of 20,000 volts. Caution should be taken while diagnosing these headlights, and testing should only take place on the battery voltage portion of the headlights, on the input side, as I said. This portion is the wiring harness traveling to the ballast igniter and back. Never should one test the high voltage exiting the ballast igniter. Always follow the manufacturer's recommendations and warnings. Failure to follow safety warnings can lead to injury and or fatality. Go to a DC voltage test, we can see where to hook it up. So headlamp low control right there. And it's there. It's the red wire on the left and a pink one on the right. And we can see how each of the wires goes in there. And then we want to check it. That has to be above 9 volts for that to work. Go on a scanner, see what we can do there. So categorized modules, that makes it easier. So we have adaptive front lighting. Codes, data, functional tests. We got some system tests in here. So there's a calibration involved for it. So after you replace the ECU or a height sensor after downloading parameters to a vehicle without electronically controlled suspension, we need to calibrate it. So it's going to go through, it's going to calibrate. In this case, it's a demo and it says their front and rear sensors out of limits, so that won't work. But on a normal car, it would. And there's also this parameter download in here as well. It's kind of like an as-built chart. So this is going to give me a fail at the end too, but all it is just going to ask you a bunch of questions about the car. How is the car outfitted? So it's left-hand drive, and let's say it's an automatic, and it's got air suspension and HIDs, and it's four-wheel drive, and it's based in North America, and it has a bifunction headlights, and it's a hatchback. All right, that's going to say failure because I'm not hooked up to a car, but you could go through and you can update the parameters in the module when you replace it. So that's pretty helpful. Functional test for this. Let's see what we got, if any. Not available because we're not hooked up to a car. Okay. So that's adaptive lighting and HID lighting on this Genesis. Let's go to the next thing. So it's another adaptive lighting on this Lexus. Let's see, headlight replace. So we got plenty of information on that. Going to wiring diagrams real quick. And there's my headlight modules there on the bottom. Go. So we got a cooling fan there, headlight leveling motor, high and low beams there. Also going to have our ground there, low side, high side LIN on this as well. So there's a network bus involved here as well. So a lot of network stuff going on, especially on these newer vehicles. We got CAN high and low right there as well. So it looks like the this side, which is the left side, it's got the computer data lines, and then it sends information over a LIN over there. And these ones are a little more fancy. So let's see. After repair information, it's going to tell you how to initialize it using the scan tool if you need to. And then parts and labor, let's see. So 2.7 hours, got to remove the bumper again, $2,900. So we went from 1,700 to 2,900. These are a little bit more fancy. Going to guide a component test on this one again. Body electrical, exterior lighting, headlight assembly. And we can go in there. It says, let's see. Headlamps are self-contained ECUs. The relay for each lamp provides 12 volts when on. The relays are ground side controlled by the main body ECU. Beam control is commanded over the CAN bus. The lamps are connected to each other by either a LIN bus or a dedicated CAN bus, depending on the system. We have our picture of our connectors there. And then it's, of course, connected to the lamp. And then we can do a DC voltage test, check for 12 volts from the relay, chassis ground, check for 12 volts there. Also check the data bus. You can check to make sure the signal's getting there as well with that. Scanner, see what we can find in there. Okay. Adaptive front lighting and automatic high beams. So we go to automatic high beams. Some actuator test there, and you can actuate it on and off, the automatic on and off. Not a lot exciting there. Come back to adaptive front lighting. System tests. All sorts of on-off functions, different pattern settings. You can go from different light patterns, make sure they're working properly. Bad weather function, headlight shade angle settings, standard or small, different patterns again. Wide light functions on and off. So there's a lot of different things that these lights can do, and you can change the patterns and make sure they're all working the way they should. So it's kind of pretty comprehensive there. Let's look at actuator tests. So drive the leveling motor, drive the swivel motor left and right on either side of the vehicle as well. Right. Let's look at this Mercedes. It's got those LED lights we saw before. There's TSBs on these too. Multi-beam headlamp fault in there. So this actually needs a software update. So that's a flash on that. If it causes a certain problem, certain code in there, going to need a flash. Wiring diagrams we talked about earlier. Dynamic LED headlamp so it can actually dim the bulbs dynamically. There's one of them. So it can dim it dynamically. We got our computer data lines right there. So it goes out to the CAN bus, position sensors, fan motors, and so on. Range adjustment actuator motor as well. So we can send the range a little bit further down the road. And then let's see cost on these. Oh, this one's VIN specific. So you actually have to call the dealer, but it's 2 hours to do both sides. Let's see what we have in the scanner. It's LED matrix there as well as in the lighting. Let's see what this one's got. It's self-test the LED matrix system. The actuator test, we can check the light distribution, LED exterior lights, resetting operating hours. So if you replace it, you want to reset the operating hours back down to 0. I'm sure there's a PID for that. Let's go all the way down the lights. I think we're going to have similar stuff down here too. Left headlamp. LED matrix module. So that's the same type of thing. Reset the numbers. Let's go to a different module. We can do the self-test again. Actuator tests, light distribution, and fan motor in that case. A lot of things can be done there. And last one, let's look at those laser lights. Now, there's not a ton of information on these. I'm sure it's available if we call. TSB's on this one too. High beam headlight failure, fault message, dimmer discolor. There's actually a recall on the light lens as well. So they actually give you pictures. Here's what it would look like. So that's not good. And that's good. So it should be white in color instead of the bluish color there for the laser lights. Another picture there. Let's see, wiring diagrams. We can go in and actually look at what's involved in the light itself. So we have high beam, low beam, parking lights, laser motorway beam pattern, headlight beam throw adjustment, parking lights, adaptive swivel modules, fan. So all of that goes in as well. Not a lot of connectors there either. And then let's look at parts and labor. So almost 4 hours to do both. And if you're replacing that laser headlight, you better be really good and sure that it needs that laser headlight, because it's $6,000 for a headlight. That's crazy. But I guess that's to be expected with fancy laser beams on the car, right? $6,000 retail from the manufacturer. Once again, not a ton going on in here either, because it is a fairly new system. We can go into the headlight module itself. A couple actuator tests in there. You can do the fans, you can reset, do the low beams, functional text, go through the LED light elements. You can turn them on and off, etc. So a lot of functionality in the scan tool you'll need. Sometimes we can test them with a guided component test as well. Always be good to refer to your wiring diagrams, make sure you know where are the relays, how's everything look. before we go in and condemn a $6,000 laser. Okay. That one might be going back to the dealer. I don't know. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, oh, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/Snap-on Diagnostics UK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully, you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.